Good morning, friends. Today we are going to discuss the syllabus of the physics for the semester 1. There are the two papers for this semester, paper 1 and the paper 2. In the paper 1 it is called as a classical physics, whereas the paper 2 is called as a modern physics. In the unit 1 of the paper 1, we have to talk about Newton's laws, elasticity, fluid dynamics. In the Newton's law, first, second and the third law of motion, interpretation and applications, pseudo forces, inertial and inertial frame of reference, work out examples with the frictional piston, elasticity, review of elastic constant, lambda, k, eta and sigma, equivalence of the shear strain to the compression and extension strains, relation between the elastic constants, couple for twist in cylinder. Then we have to talk about fluid dynamics, that the equation of the continuity, Bernoulli's equation, application of the Bernoulli's equation, streamlined the turbulent flow, lines of the flow in the aerofoil, Poiseuille's equation. In the unit 2 of the paper 1, we have to talk about the length maker formula, its review, Newton length equation, magnification, lateral, longitudinal, angular, equivalent focal length of the two thin lenses, thick lenses, cardial points of the thick lens, then the Ramsden, there's Ramsden Huygens eyepiece, aberrations, spherical aberration, reduction of the spherical aberration, chromatic aberration and the conditions for the chromatic aberration, interference in the thin films, fringes in wedge-shaped film, Newton rings. Then in the unit 3, we have to talk about the behavior of the real gases and the real gas equation, van der Waals equation, thermodynamic system, zeroth law of thermodynamics, concept of the heat and the first law, non-adiabatic process and the heat as a path, internal energy, heat capacity and the specific heat, application of the first law to simple processes, general relation from the first law, indicator diagram, work done during the isothermal and adiabatic processes, work example, problems. These are the part we have to cover in the paper 1. Very simple. Both the paper having the 100 marks weightage. There are the 3 units in each paper. First paper is called as the classical physics. In that, in the unit 1 we have seen Newton's law is there, elasticity is there, fluid dynamics is there. Then the unit 2 is having lens, about the lens, then the aberration and the interferences, and in the third unit there is a thermodynamics, you can call it, and about the real gases and the van der Waals equations. Then in the paper 2, the paper 2 is nothing but modern physics. Again, here are the 3 units. In the unit 1, we have to talk about the structure of nuclei, basic properties of the nuclei, composition, charges, size. Then the Rutherford's experiment for the estimation of the nuclear size, density of the nucleus, mass defect and binding energy, packing fraction, binding energy per atom versus that particular plot we have to see. Then the stability of the nuclei and the problems. Then the radioactivity we have to see, radioactivity disintegration concept of the natural and artificial radioactivity, properties of the alpha, beta, gamma rays, laws of radioactive decay, half-life, mean life, units of the radioactivity, successive disintegration and the equilibrium, radioisotopes, numerical problems. Then the next, the carbon dating and other applications of the radioactive isotopes, agricultural, medical, industrial, archaeological information from the net. Then in the unit 2, we have to talk about interaction between the particles and the matter. In the second unit of the paper 2, we have to talk about the interaction between the particles and the matters, ionization chamber, proportional counter and the GM counter, nuclear reactions, types of the reactions and the conservation's law, concept of the compound and the direct reaction, key value equation and the solution of the key equation, problems, fusion and the fissions, Okay. In the unit 2 of the paper 2, we are going to discuss these things. Then the nuclear reactions, types of the reactions and the conservations law. Then the concept of the compound and a direct reaction, key value equation and solution of the key equation. Then the problems, then the fusion and the fission, their definition and their qualitative discussion with the example we have to see in the unit 2. Then in the unit 3 of this paper 2, we have to talk about origin of the quantum theory, black body spectrum, Wien's displacement law, matter waves, wave particle duality, Heisenberg uncertainty principle, division, and Germer experiment, G.P. Thomson experiment that we have to see. Then the X-ray production and the properties, continuous and the characteristic X-ray spectra, X-ray diffraction, Bragg's law, application of the X-rays, Compton effect, pair production, protons, and gravitational redshift. These much things we have to discuss in the paper 2. And in the two papers we have to talk about these practicals. J by electrical methods are there. Out of this, whatever the limited practical we will take, here we have the choice. We can take, there are the 5 skill experiment. See here, minimum 8 experiments from the list of that should be completed in the first semester. Any 4 skill experiment that we have to report in the journal. Okay, these are the required things that we will see during the practical. Which practical we have to take, that we will decide during the practical session. But you have to remember that in the paper 1 there are the 3 units, in the paper 2 there are the 3 units. I said first paper is of the classical physics and the second paper is of the that particular modern physics. Okay, we will start with this particular papers, and your exam pattern will be the online MCQ based. For that purpose we have to see in detail about this, because MCQ will be there on the each and every part of this particular unit. This is about the syllabus of this physics for this semester, first for the paper 1 and the paper 2, and this is for the practicals. Okay, please go through this well. If you have any problem you can ask well. Okay, here we will stop. Thank you.